Welcome back, students, to the second lecture of the six-part series. In the previous lecture we talked about what is a technology development project and why is it different to other projects. Now today we'll be talking about what are the different processes of managing technology development projects. Now the main thing you need to know is that you don't use traditional methods for non-traditional projects. In the previous lecture, we discussed why TD projects were so special. Another reason is that they are fragile. If one applies traditional management techniques to non-traditional projects, much damage is done. For example, force-fitting a TD project to your normal new product system will create considerable frustration on the part of the project team, which will result in unnecessary or irrelevant work and could even kill an otherwise high-profit potential initiative. Exxon Chemical was one of the first companies in the United States to recognise that such research or technology development projects required special treatment, and that ramming them through their traditional management processes would do much harm. Thus, by the 1990s, Exxon Chemical had designed and implemented a special methodology based on stage and gate techniques to handle such high-risk technology projects. The fact is that traditional systems simply do not work for these special technology projects. Why? Traditional new product processes are designed for fairly well-defined and predictable projects. Technology development projects, however, are by their nature high-risk projects, with many unknowns and great technical uncertainties. For example, early in the life of such projects, the likelihood of technical success may be quite low, and a probable technical solution often cannot be envisioned. It may take months or years of lab work to see a technical solution and to gain confidence in a positive technical outcome. Similarly, the traditional new product process requires a full business case and financial analysis before heavy commitments are made. However, in a technology project, the commercial prospects for the new technology are often unclear, especially near the beginning of the project, when these commitment decisions are required. In the Exxon Chemical Metallocene project, for example, when experimental work first began, it wasn't clear whether this would lead to a new plastic or perhaps a new fuel additive. All the researchers had in the early days was some gummy stuff with some interesting properties. The precise direction of the project would not become clear until the researchers had done more work at a considerable expense. This is not exactly the reassurance that a short-term financially driven executive wants to hear. Many of the activities required of most companies' new product processes simply don't fit the TD project. Review any company's new product process and invariably there is a list of required tasks such as undertake a competitive analysis, do voice of customer work, and define the product benefits to the user. That's fine when no one knows what the market is, or what the product is. But how does one undertake such mandatory activities when the market is unknown and the project not even defined? Moreover, most companies' new product processes require a list of deliverables at the completion of each stage, deliverables such as a business case or a commercialization plan. Again, these are relatively meaningless concepts when the product and market have not yet been defined. As one frustrated product leader put it, how can I be expected to do a market analysis when I haven't even defined the project, let alone the market yet? I'm not even sure what this technology is capable of in terms of delivering improved technical performance. Now here we have the goal-kill criteria, which is used to rate and prioritise development projects as found in most companies' stage and gate development processes. Again, assume projects that are fairly well defined. For example, an Industrial Research Institute study revealed that 78% of businesses rely heavily on financial criteria to select projects. Criteria such as projected annual profits, NPV, net present value, and expected sales. When qualitative criteria are employed, according to the same study, The most popular are leveraging core competencies, for example, the project's fit with the plant and fit with the firm's base technology, the expected payoff, and the perceived risk level. These quantitative and qualitative terms are fine for the majority of the development projects, but are not so good for technology developments. A seasoned research and development executive in a major corporation summarised the situation in this way. Using traditional go-kill criteria of NPV.KOI, return on investment essentially, and the like, will almost guarantee that new technology projects are killed in our company simply because of the unknowns, the uncertainties, and the risks, and the step-out nature of such projects. Our selection rules are very risk-averse and geared towards short-term projects. Now, use a process designed for technology development projects. For some years now, leading product developers have relied on idea to launch processes such as stage gate to drive new product projects to the market. The conclusion at a conference of the Product Development Management Association, the PDMA, that focused on technology developments and fuzzy front-end projects was that many companies shaved dramatically improved development cycle time and efficiency by implementing formal stage gate systems, but that the front end remained a mystery. The consensus is that some type of rigorous staging gate process is desirable for technology development projects, but the process must be custom designed for each of these types of projects. Some type of rigorous staging gate process is desirable, but it must be custom designed. The figure later on in the lecture illustrates a typical technology process which has been adopted in leading companies that undertake fundamental research projects. They consist of 3 stages and 4 gates. Each stage consists of a set of best practice activities to be undertaken by the project team. These activities are designed to acquire vital information and thereby reduce the unknowns and hence the risk of the project from stage to stage. The outcome of each stage is a specified set of deliverables. The gates, designated by diamonds, are the go-kill decision points. Here, management meets with the project team to decide whether the project merits additional funding and resources to move to the next stage. If go, resources are committed at the gate and the project team move forward. Here is a quick walkthrough of a typical TD process. Discovery. The trigger for the process is the first stage, involving discovery or idea generation. Quality ideas are essential to a successful technology program, and thus technology ideas from multiple sources must be sought for consideration at Gate 1. Whilst idea generation is often done by scientists or technical people, it can also be the result of other activities, such as a strategic planning exercise when strategic arenas are identified and possible TD research directions are mapped. Technology forecasting and technology road mapping. Brainstorming or group creativity sessions focus on what might be. Scenario generation about future market and technological possibilities. Customer visitation programs and voice of customer initiatives. Active idea solicitation campaigns within the organisation. Gate 1, the idea screen. The first gate is the idea screen, the initial decision to commit a limited amount of time and money to the research project. This gate should be a general screen which poses the question, does the idea merit expending any effort at all? Criteria for go are largely qualitative and are scored at the gate review by the gatekeepers and should include such items as strategic fit and impact, strategic leverage, likelihood of technical success, likelihood of commercial success, and reward or the size of the price if successful. The Gate 1 gatekeeper or decision making group is technically composed of senior research and development people, such as the corporate head of technology, the vice president of research and development or the commanding technical officer, and other senior R&D people, along with representatives from the corporate marketing and business development to ensure commercial input. Stage 1. Project scoping. The purpose of the scoping stage is to build the foundation for the research project, define the scope of the project, and map the forward plan. The effort is limited, typically to not much more than 2 weeks. Stage 1 activities are conceptual and preparation work and include a technical literature search, patent and IP search, competitive alternatives assessment, resource gaps identification, and a preliminary technical assessment. Gate 2. Go to technical assessment. The second screen is the decision to begin limited experimental or technical work in Stage 2. Like Gate 1, this gate is also a relatively gentle screen and poses the question, does this idea merit undertaking limited experimental work? Gate 2 is again largely qualitative and does not require financial analysis because the resulting product, process or impact of TD are still largely unknown. The gatekeepers here are the same as Gate 1. Stage 2. Technical assessment. The purpose of Stage 2 is to demonstrate the technical or laboratory feasibility of the idea under ideal conditions. This stage entails initial or preliminary experimental work, which should not take more than 1 to 2 person months, and last no longer than 3 to 4 months. Activities here typically include undertaking a thorough conceptual technological analysis, executing feasibility experiments, developing a partnership network, identifying resource needs and solutions to resource gaps, and assessing the potential impact of the technology on the company. Gate 3. Go to detailed technical investigation. Gate 3 is a decision to deploy resources beyond 1 to 2 person months and opens the door to a more extensive and expensive investigation. Stage 3. This gate decision is thus a more rigorous evaluation than at Gate 2 and is based on new information from Stage 2. Gate criteria resemble those listed for Gate 1 previously, but with more and tougher sub-questions and answered with benefit of better data. The Gate 3 gatekeepers usually include the corporate head of technology, again the Vice President of Research and Development, or the commanding technical officer, or other senior technology or R&D people, corporate marketing or business development, and the heads of the involved businesses, e.g. general managers. Because Gate 3 is a heavy commitment gate, senior managers of the business units that will take ownership of the resulting technology should be the Gate 3 gatekeepers. Their insights into the commercial viability of the project are essential at Gate 3. Furthermore, early engagement ensures a smoother transition to the business unit once the commercial phase of the project gets underway. Stage 3. Detailed investigation. The purpose of Stage 3 is to implement the full experimental plan, to prove technological feasibility, and to define the scope of the technology and its value to the company. This stage could entail significant expenditures, potentially person-years of work. Besides extensive technical work, other activities focus on defining commercial product or process possibilities, undertaking market, manufacturing and impact assessments on these possibilities, and preparing an implementation business case. Sound project management methods are employed during this lengthy stage, including periodic milestone checks and project reviews. If the TD project veers significantly off course or encounters serious barriers to completion during Stage 3, the project is red flagged and cycled back to Gate 3 for another go-kill decision. Gate 4. The applications path gate. This is the final gate in the TD process and is the door opener to one or more new product or process development projects. Here the results of technical work are reviewed to determine the applicability, scope and value of the technology to the company, and the next steps are decided. Note that this Gate 4 is often combined with an earlier gate in the usual product development process. For example, with Gate 1, 2 or 3, as shown in the figure previous, gatekeepers are technically the senior corporate R&D people, corporate marketing or business development, plus the leadership team from the relevant business that will assume ownership of the resulting commercial development projects. Now, how technology development projects process feeds the traditional process. The final gate of the TD process is the applications path gate, which marks the end of the TD project, but potentially the beginning of multiple commercial projects. It is here that the project team presents their conclusions about the commercial prospects of the technology, based on technical work to date and several quick commercial scoping exercises. At this point, multiple new product projects could be initiated and feed the typical new product process. The start points are usually gates 1, 2 or 3 of the new product process, depending on how well defined the proposed new projects are. Alternatively, if the commercial result is a new or improved production process, then the appropriate process development projects are defined here and routed accordingly. The TG project may also result in a licensing opportunity or perhaps even a joint venture with another corporation. The point is that the applications path gate determines the direction for the commercialization of the technology from this point onwards. The figure above is the typical technology development process spawns multiple commercial projects that can feed the new gate product process at gates 1, 2 or 3. Now this here will mark the end of this lecture. Feel free to add any questions you may have to the forums, as I see many of you have already have. There is no tutorial for this lecture, so keep on reading the recommended reading if you've chosen to purchase or if you've found a copy of the book, as it will further highlight the processes that I have stated in this lecture. So join us for the third part of the 6-part series, where we will be talking about ensuring you pick the right projects and why. Thanks for listening.